Download this code from codegive.com, link in the description below. OK, let's dive deep into Amazon EventBridge, SQS, Simple Queue Service, and SNS, Simple Notification Service, exploring their functionalities, differences, and when to use each. We'll include code examples to illustrate practical application. Understanding the core services. Before comparing, let's establish a solid understanding of each service. Amazon EventBridge, the event router/broker. What it is. EventBridge is a serverless event bus service. It allows you to build event-driven applications at scale by routing events between AWS services, integrated SaaS applications, and your own applications. It acts as a central hub for events, enabling different components to react to changes in the system without direct dependencies. Key concepts. Events represent a change in state, an update, or an action. Events are structured data in JSON format. For example, an order was placed, a new user was created, or an EC2 instance state changed. Event bus. The central container for events. You can have a default event bus or create custom event buses to isolate different environments or application segments. The default event bus receives events from AWS services. Rules. Define how EventBridge responds to incoming events. Rules consist of event pattern. Specifies the characteristics of the events the rule should match. This can be based on the source, detail type, and fields within the detail object of the event. Targets. Define what actions to take when a matching event is received. Targets can be AWS services, Lambda functions, SQS queues, step functions, state machines, etc., or integrated third-party SaaS applications. You can have multiple targets for a single rule. Source. The entity that originates the event. This could be an AWS service, example EC2, S3, CloudWatch, a custom application, or a SaaS application. Detail type. Further classifies the type of event within a source. For example, if the source is S3, the detail type might be object created or object deleted. Partner event bus. Enables you to receive events directly from SaaS applications supported by EventBridge. This eliminates the need for polling or custom integrations. Schema registry. A repository for event schemas that helps you discover, understand, and validate the structure of your events. Key features. Event filtering. Route events based on complex criteria using event patterns. Transformation. Transform the event data before it is sent to the target. Schema discovery and validation. Automatically discover event schemas and validate events against those schemas. Retry policies. Automatically retry failed event deliveries to ensure reliability. Dead letter queues. DL queues send undeliverable events to a DL queue for troubleshooting and reprocessing. Scheduled events. Cron-based trigger events on a regular schedule, similar to cron jobs. API destinations. Call an API endpoint using EventBridge. Archive and replay. Archive events and replay them for debugging or testing purposes. Global endpoints for disaster recovery. Set up active/passive disaster recovery for EventBridge using global endpoints. Amazon SQS, Simple Queue Service, the message queue. What it is. SQS is a fully managed message queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. It allows different parts of your application to communicate and exchange data without being directly connected. It provides a reliable and scalable buffer between components. Key concepts Q a buffer that holds messages waiting to be processed. There are two main queue types. Standard queue offers best effort ordering. Messages are generally delivered in the order they were sent, but not guaranteed. It provides near unlimited throughput. Messages can be delivered more than once. FIFO, first in, first out, Q** guarantees that messages are processed exactly once, in the exact order they were sent. FIFO queues have a lower throughput limit than standard queues. They require a message group ID for ordering. Message the data being transmitted. Messages can contain up to 256 KB of text, XML, JSON, and unformatted binary data. Producer the application or service that sends messages to the queue. Consumer the application or service that retrieves and processes messages from the queue. Visibility timeout the amount of time a message is invisible to other consumers after it has been retrieved by a consumer. This prevents multiple consumers from processing the same message simultaneously. If the consumer doesn't delete the message within the visibility timeout, it becomes visible again. Message retention period the amount of time SQS retains a message in the queue if it is not consumed. The retention period can range from 1 minute to 14 days. Dead letter queue, DLQ a special queue where messages that cannot be processed successfully after a certain number of retries are sent. This allows you to investigate and address issues with problematic messages. Key features decoupling decouples producers and consumers, improving application resilience and scalability. Asynchronous processing allows consumers to process messages at their own pace, independent of the producers. Message buffering handles spikes in traffic by buffering messages in the queue. At least once delivery, standard queues guarantees that messages are delivered at least once, but potentially multiple times. Exactly once delivery, FIFO queues guarantees that messages are delivered exactly once, in the order they were sent. Scalability automatically scales to handle increasing message volumes. Visibility timeout prevents multiple consumers from processing the same message. Dead letter queues enables you to identify and address problematic messages. Message grouping, FIFO queues allows you to group related messages together and process them in order. Long polling reduces costs and latency by allowing consumers to wait for messages to arrive in the queue. Server-side encryption, SSE encrypts messages at rest using keys managed by AWS KMS. Access control control who can send and receive messages from the queue using IAM policies. See Amazon SNS, Simple Notification Service, the pub/sub messaging service. What it is SNS is a fully managed pub/sub messaging service for decoupling microservices, distributed systems, and serverless applications. It allows you to send notifications to a large number of subscribers using various protocols, HTTP/S, email, SMS, mobile push notifications, and SQS. Key concepts topic a logical access point and communication channel. Publishers send messages to a topic, and subscribers receive messages from the topic. Publisher the application or service that sends messages to the SNS topic. Subscriber the application, service, or user that receives messages from the SNS topic. Subscribers can subscribe to a topic using different protocols, example http/s, email, SMS, AWS Lambda, SQS. Message the data being transmitted. Messages can contain up to 256 KB of text, XML, JSON, and unformatted binary data. Subscription defines the relationship between a topic and a subscriber. It specifies the protocol and endpoint to which messages will be delivered. Subscription filter policies enable subscribers to receive only the messages that they are interested in. Filters are based on message attributes. Key features pub/sub messaging enables publishers to send messages to multiple subscribers simultaneously. Broadcasting distributes messages to a wide audience using various protocols. Fanout distributes messages to multiple endpoints, allowing for parallel processing of messages. Scalability automatically scales to handle increasing message volumes. Message filtering allows subscribers to filter messages based on attributes. Message persistence, using SQS can be combined with SQS to provide message persistence and reliability. Mobile push notifications supports sending push notifications to iOS, Android, and other mobile devices. SMS notifications supports sending SMS messages to mobile phones. Email notifications supports sending email messages. Direct integration with AWS services integrates seamlessly with other AWS services like SQS, Lambda, and CloudWatch. Server-side encryption, SSE encrypts messages at rest using keys managed by AWS KMS. Access control control who can publish to a topic and subscribe to a topic using IAM policies. 2. Key differences and when to use each service. Now, let's compare and contrast these services. Feature: Amazon EventBridge, Amazon SQS, Amazon SNS. Paradigm Event Router / Broker Message Queue Pub / Sub Messaging. Purpose-built event-driven applications by routing events. Decouple applications and services for reliable asynchronous communication. Send notifications to a large number of subscribers using various protocols. Event/message format: structured data, JSON, up to 256 KB of arbitrary data, up to 256 KB of arbitrary data. Delivery guarantees: at least once, configurable retries, at least once, standard, exactly once, FIFO, at least once. Fanout: yes, using multiple targets, no, point-to-point, yes. Filtering: complex filtering based on event patterns, no filtering at the queue level. Yes, using subscription filter policies. Invocation: push, to targets, pull, consumers poll the queue, push, to subscribers. Ordering: limited within event patterns, best effort, standard, guaranteed, FIFO, no ordering guarantees. Use cases: application integration, SaaS integration, event-driven architectures, reacting to AWS service events. Decoupling services, background processing, buffering messages, task queuing. Sending notifications, email, SMS, mobile push, distributing events to multiple consumers, fan-out scenarios. In more detail: EventBridge versus SNS EventBridge is best when you need to route events based on complex criteria, transform events, integrate with SaaS applications, or build event-driven architectures where different services react to specific events. It focuses on routing and transforming events. *SNS is best when you need to broadcast messages to a large number of subscribers, send notifications, email, SMS, push, or distribute events to multiple consumers in parallel. It focuses on notification and fanout. Think of EventBridge as a sophisticated router with advanced filtering and transformation capabilities, while SNS is a simple broadcast service. SQS versus SNS SQS is best when you need reliable, asynchronous communication between services, background processing, or message buffering. It guarantees message delivery and provides a mechanism for handling failed messages. SNS is best for notification and fanout scenarios. SQS is point-to-point, one consumer processes each message, while SNS is pub/sub, multiple subscribers can receive the same message. SNS can be used to trigger SQS queues in a fanout scenario. One SNS topic sends messages to multiple SQS queues. EventBridge versus SQS EventBridge is best for routing events and building event-driven architectures. It handles events in a structured JSON format and allows for complex filtering. SQS is best for reliable, asynchronous communication and message buffering. It handles messages in an arbitrary format and provides message persistence. EventBridge pushes events to targets, while SQS requires consumers to pull messages from the queue. You might use EventBridge to route events to SQS queues for asynchronous processing. 3. Code examples. Let's illustrate these concepts with some code examples using the AWS SDK for Python, Boto3. Make sure you have Boto3 installed, pip install Boto3. Configure your AWS credentials appropriately, using environment variables, IAM roles, or the AWS CLI. EventBridge example, sending and receiving events. Explanation *. 1. Send an event *. The send_event function sends an event to the EventBridge event bus. The event includes source, detail type, and detail fields. The detail field is where you put the specific data related to the event. 2. Define an EventBridge rule *. You define a rule that specifies which events should be routed to which targets. The example above uses the AWS CLI to create a rule that matches events with source equal to my.application and detail type equal to order.created. You can also create these rules in the AWS console. 3. Add a target to the rule *. The rule needs a target. What should happen when a matching event is received? The example adds a Lambda function as a target, meaning the Lambda function will be invoked when a matching event is received. You'd create the Lambda function separately. The function's ARN, Amazon resource name, is needed to configure the target. For Lambda function, target. The Lambda function receives the event as input. It extracts the relevant data from the event detail object and performs the necessary processing, in this example, printing the order details. SQS example, sending and receiving messages. Explanation *. 1. Create a queue * creates an SQS queue with the specified name. It includes error handling to check if the queue already exists. The delay seconds attribute delays message delivery for a specified time. 2. Send a message *. The send_message function sends a message to the specified SQS queue. The message body can be any text-based data. 3. Receive messages *. The receive_messages function retrieves messages from the queue. It uses long polling, wait time seconds equals 20, to reduce costs and latency. It processes the message, then deletes it from the queue using the receipt handle. Important *. You must delete the message after processing it, otherwise, it will become visible again after the visibility timeout expires and may be processed multiple times. See SNS example, publishing and subscribing. Explanation asterisk. 1. Create a topic asterisk creates an SNS topic, which is the channel for sending messages. 2. Subscribe to the topic asterisk the subscribe _to_ topic function subscribes an endpoint to the topic. You can subscribe email addresses, phone numbers, for SMS, SQSQs, Lambda functions, and HTTP/HTTPS endpoints. Note that for email subscriptions, the recipient will need to confirm the subscription by clicking a link in a confirmation email. For SQS subscriptions, you need to grant SNS permission to publish to the SQSQ. 3. Publish a message asterisk the publish _message function sends a message to the topic. Subscribers to the topic will receive the message via their chosen protocol, example email, SMS, SQS. 4. Putting it all together, a combined example. Let's imagine a scenario where you have an e-commerce application. 1. Order placement asterisk when an order is placed, your application sends an event to eventbridge. 2. Event routing asterisk an eventbridge rule matches the order.placed event and routes it to asterisk an SQSQ for asynchronous order processing, example inventory updates, payment processing. This provides decoupling and resilience. Asterisk an SNS topic to send a notification email to the customer confirming their order. 3. Asynchronous processing asterisk a worker process consumes messages from the SQSQ, processes the order, and updates the inventory. 4. Customer notification asterisk the SNS topic sends an email to the customer confirming their order. Benefits asterisk decoupling asterisk the order placement service doesn't need to directly call the inventory update or notification services. Scalability SQS can handle spikes in order volume. SNS can send notifications to a large number of customers. Flexibility you can easily add new targets to the eventbridge rule to react to the order.placed event in different ways. Example code snippets order placement service sends event to eventbridge, see eventbridge example above. Eventbridge rule as configured above. SNS topic for notifications, see SNS example above. SQS worker processes messages from the queue, see SQS example above. V considerations and best practices. Security use IAM roles and policies to control access to eventbridge, SQS, and SNS. Encrypt messages at rest and in transit. Error handling implement retry policies and dead letter queues, DLQs, to handle failed events and messages. Monitoring monitor the performance of your eventbridge rules, SQSQs, and SNS topics using CloudWatch metrics. Set up alarms to alert you to potential issues. Cost optimization use long polling for SQSQs to reduce costs. Filter messages in SNS using subscription filter policies to avoid sending unnecessary messages to subscribers. Optimize your eventbridge event patterns to avoid processing unnecessary events. Consider the retention period for messages in SQSQs and events in eventbridge archives. Event schema management use eventbridge schema registry to discover, manage, and validate event schemas. This helps ensure that your events are well defined and consistent. Choosing the right queue type. SQS use FIFO queues if ordering and exactly once processing are critical. Use standard queues for high throughput and when ordering is not critical. Visibility timeout. SQS set the visibility timeout appropriately for your application. It should be long enough for the consumer to process the message but short enough to avoid delays if the consumer fails. 6. Conclusion. Amazon EventBridge, SQS, and SNS are powerful services that can help you build scalable, resilient, and decoupled applications. By understanding their differences and use cases, you can choose the right tool for the job and design robust event-driven architectures. Remember to consider security, error handling, monitoring, and cost optimization when using these services in production. This comprehensive guide should give you a very solid foundation for using these AWS services. Remember to test and refine your implementations as you build out your applications.